In this video, we'll look at integration by parts with definite integrals. We'll start by finding u and dv. Typically, we want u to be the part that when we differentiate, we get a simpler expression. For example, if we look at x and take its derivative, we get 1, which is simpler. So we'll let u be x. That means dv is e to the x dx. Now focusing on u, we want to find du, its derivative. The derivative of x is 1 dx, or simply dx. And then focusing on dv, we want to integrate it to find v. The integral of e to the x is e to the x. We can now rewrite the original integral using the formula for integration by parts. That is u, which we're calling x, v, e to the x, and as a reminder, we are evaluating from 0 to 1, minus the integral from 0 to 1 of v, e to the x, du, dx. Let's now rewrite this as x e to the x. If we evaluate this integral, the integral of e to the x is e to the x. So we'll have minus e to the x, and all of this is being evaluated from 0 to 1. Now we'll plug in that upper limit, 1 times e to the first power, minus e to the first power, minus, let's plug in 0. 0 times e to the 0 minus e to the 0. E minus e is just 0 minus e to the 0 is 1 times 0 is 0 minus e to the 0. E to the 0 is 1, so we get minus 1 there. And then minus negative 1, if we distribute that negative sign, will give us 1. In this example, we are again integrating using parts. Let's let u be theta. Then dv has to be sine of 3 pi theta. Focusing on the u, we'll take its derivative. Du is 1 d theta, or simply d theta. And then focusing on dv, we want to integrate it to find v. This does require a u substitution. We'll get negative 1 divided by 3 pi cosine 3 pi theta. Going back to the original, u is theta times v, that is negative 1 divided by 3 pi cosine of 3 pi theta. I'll just remind myself we are evaluating from 0 to 1/2. Then we have minus the integral from 0 to 1/2 of v, negative 1 divided by 3 pi cosine 3 pi theta du, which we said is d theta. In the first part, we can simplify a tiny bit, just putting that theta in the numerator. And I'll drop the limits for now and put those back in at the very end. We now need to integrate, but notice that we have a constant out front of cosine, so we can pull that constant out. Note the double negative will make that plus 1 divided by 3 pi. And now the integral of cosine of 3 pi theta. Again, this is going to require a u substitution. That is 1 divided by 3 pi sine of 3 pi theta. And all of this is being evaluated from 0 to 1/2. Next, let's go in and plug in those limits. First, we'll plug in 1/2. Plugging in 1/2 here will give us negative 1 divided by 6 pi times the cosine of 3/2 pi plus 1 divided by 9 pi squared times the sine of 3/2 pi. Then we need to subtract and plug in the lower limit 0. Plugging in 0 to this first term will just make that 0. And then we get plus 1 divided by 9 pi squared sine of 0. We now have negative 1 divided by 6 pi. Cosine of 3 pi halves is 0. Plus 1 divided by 9 pi squared. Sine of 3 pi halves is negative 1 minus 0 plus sine of 0 is 0. So simplifying once again, we get negative 1 divided by 9 pi squared.